Hello everyone, how are you today? I hope you are fine. Today is Tuesday, 25 March 2020. Our lesson today about inequality. In this video, we will learn how to solve one-step inequalities. What is an inequality? An inequality is a mathematical sentence that contains one or more of the following inequality symbols. There are 4 inequality symbols, and they show that the value of one expression is greater than the other. On the first row, we have a greater than symbol. This is called a greater than symbol, which would say x is greater than c. On the second row, we have a less than symbol, which would say x is less than c. The third row, we have greater than or equal to symbol. That tells us that x is greater than or equals to c. The last one, this is the less than or equal to symbol, which tells us that x is less than or equal to c. And yesterday, we knew that the mathematical sentence that have an equal sign are called equations. These equations, x plus 3 equals 5. X plus 3 is equal to 5. In equations, both sides of the equal sign have the same value. But in inequality, one side is greater than the other. For example, here we have, on the left side, we have 3 plus 2, which is 5. And on the right side, we have 4. The left side 5 is greater than the right side. So here 5 is greater than 4. When working with inequalities, we will often need to solve them, and this means to find a range of values that a variable x can take to make the inequality true. If we look at the inequality, x plus 1 is greater than 10. To solve this inequality, we would need to find all of the values that makes x plus 1 greater than 10. And that's what we are going to learn how to do in this video. Before we look at solving for inequalities, let us quickly remember the balance method when we are working with equations. An equation states the equality between two expressions. We can represent it with a balance scale. In this case, we have a balance scale. On the left side, there is x plus 5, and on the other side, there is 8. And x plus 5 is equal to 8. The scale is balanced. If we want to find the value of x, we use the opposite operation. By subtracting 5 from both sides of an equation, we get subtract 5 from the left side, we get x by itself. Subtract 5 from the right side, we get 8 minus 5 equals to 3. So we get x equals to 3. Now, let's look at how this applies to inequalities. There is the scale here. In this case, we want to say that x plus 5 is greater than 8. X plus 5 on the right side, on the left side, is greater than 8 on the right side. On the scale, that means the x plus 5 side will weigh more, will be heavier than 8. It will be farther down. It will be farther down the 8. In this case, when we are solving for x, we will need to maintain this uneven scale. The x side should remain lower than the 8 side. when we solving the inequality, we should remain that the left side is lower than the right side. If we can remove 5, here the left side has x plus 5, the other side has 8. If we can remove 5 from both sides of the scale, we take away 5 from here, we get on the left side x by itself. When we remove or take away 5 from the right side, we get 8 minus 5 equals to 3. So we see a new inequality statement, x more than 3. We can represent this situation mathematically by subtracting 5 from both sides of the inequality, which leave us with x is greater than 3. X plus 5 on the left side, more than 8 on the right side. Subtracting 5, minus 5 from here, and minus 5 from here, we get on the left side x more than 3. The value of x could be any number more than 3. So we say that the solution set for this inequality is the set 4, 5, 6, and so on. Any number more than 3. Let's see this example. Solve the following inequality. X minus 6 is greater than 10. We need to let x by itself using the opposite operation. Since x has a subtraction operation, minus 6, so by adding 6 to both sides, we get on the left side x by itself, because negative 6 plus 6 equals 0, and on the right side 10 plus 6 equals to 16. So we get x is greater than 16. And the solution set will be any number more than 16. 17, 18, 19, and so on. Now I'm going to explain to you the properties of inequalities. We know that 6 is greater than negative 9. 6 is greater than negative 9. We call it a true inequality. If we perform some operations on this true inequality, we get another true inequalities. Number 1, if we add 2 to the two sides of the inequality. Here, the left side has 6 and the right side has negative 9. If we add 2 to the left side, we get 6 plus 2 equals to 8. On the right side, if we add 2, we get negative 9 plus 2 equals to negative 7. Is 8 is more than negative 7? Yes, it's true. So this is a true inequality. So adding a constant number to both sides of the inequality doesn't change the inequality relation. Let us see if we subtract a number. Subtract a number from the two sides of the inequality. Let us see, for example, if we subtract 7. So the left side has 6. If we subtract 7 from it, we get 6 minus 7 equals to negative 1. The right side, negative 9 minus 7. Negative 9 minus 7 will get negative 16. And we ask ourselves, is it true that negative 1 is more than negative 16? Yes, it's true. Negative 1 is more than negative 16. So this is a true inequality. So subtracting a constant number from the two sides of the inequality doesn't change the inequality relation. Let us see if we multiply the two sides of the inequality by a constant number, which is positive number. Let's see 5. If we multiply the two sides of the inequality by 5, the left side has 6. 6 by 5 equals to 30. The right side, negative 9. Negative 9 by 5 will get negative 45. According to the rules of multiplying the integers, negative by positive equals to negative. Is 30 is it true that 30 is more than negative 45? Yes, any positive more than any negative. So this is a true inequality. Multiplying the two sides of the inequality by a positive number doesn't change the inequality relation. Let us see one more operation. The last operation is divide. Divide the two sides of the inequality by positive number. Let's see 3. Let's take 3. Okay? On the left side, we have 6. If we divide it by 3, we get 6 divided by 3 equals 2. The right side, negative 9. Negative 9 divided by 3 equals to negative 3. Is it true that 2 is more than negative 3? Right or wrong? Yes, 2 is more than negative 3 because any positive is greater than any negative. So dividing the two sides of the inequality by a positive number doesn't change the inequality relation. Let us see if we multiply the two sides of the inequality by a negative number. We'll take negative 1, for example. By multiplying both sides of the inequality by negative 1. Here, the left side 6. 6 by negative 1 equals to negative 6. The right side, negative 9. Negative 9 by negative 1, negative by negative equals to positive. So it will lead to 9. Is it true that negative 6 is more than 9? No. Negative 6 is a negative number and 9 is a positive number. No, this is a false inequality. Here, in order to make a true inequality, we should change the inequality sign to the opposite side. We will correct this one. When multiplying both sides of the inequality by a negative number, it gives us a false inequality. In order to correct it, in order to get a true inequality, we should change the inequality sign. Here, it's more than. We will change it to less than. So, negative 6 is less than 9. Be careful. When multiplying the two sides of the inequality by a negative number, we should change the sign of the inequality to the opposite sign. Negative 6 more than 9, we will change it to negative 6 smaller than 9 to make the inequality true. The last one, if we divide the two sides of the inequality by negative 3, here the left side has 6. 6 divided by negative 3 equals to negative 2. And on the right side, negative 9 divided by negative 3, negative divided negative equals positive. 9 divided 3 equals to 3. Is it true that negative 2 is more than 3? False inequality. No, it's not true because negative 2 is smaller than 3. Finally, in order to make a true inequality, when dividing both sides of the inequality relation by a negative number, we should change the inequality sign to the opposite side. Let's see, this is a final example to solve a two-step inequality. Here, x has two operations, multiply 5 and subtract 2. Multiply 5 and minus 2. Okay, we start with the opposite operation of subtraction. The opposite operation of subtraction is addition. So 2x minus 8, if we add 8 to both sides of the inequality, we get on the left side 2x minus 8 plus 8, and on the right side negative 4 plus 8. Negative 8 plus 8 equals 0, so the left side will have 2x only. The right side, negative 4 plus 8 equals to 4. 8 minus 8 plus negative 4 equals to 4. Now we want to make x by itself. X has a multiply operation. To solve for x, we need to use the opposite operation, which is divide. We divide both sides of the inequality by 2. 2x divided by 2 equals x. 4 divided by 2 equals to 2. So x is less than or equal to 2. X could be any number equals to 2 or less than 2. So the value of x belongs to the range of values from 2 and smaller than 2. So the solution set equals 2, 1, 0, and so on. Thank you. I hope you understand. Thank you so much.